focus on Bayesian Inference and Naïve Bayes classification. And we hope that by the end of the lecture, or I expect that you should have a good understanding of probability fundamentals needed for Bayesian inference. I know this may be a little bit tasking, particularly for those of you coming from the linguistic class. But I believe if you, as much as one can make it or simplify it here, you still need to interact, and Peter is here to assist, as well as Honey. And then the statistics students, you can rub mind also with them, get things shared. So the second thing is you get familiar with the concept of Bayes Theorem, which is fundamental, which is the cornerstone of this of Bayesian inference, and of course for Naïve Bayes classification. The third thing, the third learning objective is that at least you should be able to implement and evaluate a Naïve Bayes classifier for text classification. You remember in our bootcamp meeting, we discussed different data that we can work with. And for linguistics, text data is also a common, it's very common in linguistics data set. So you should, in summary, you should have a good understanding of probability fundamentals. You should also know the theorem, Bayes theorem, very well. And you should know how we can apply it to classification problem. And beyond that, how do you implement it in our environment? So these are the expected learning objectives in the class. So let's start with the idea of probability. I know you've heard about probability. You have, whether you have used that knowledge is what one cannot really say. So let me ask you, what do you know about probability? Anybody in the linguistic, anyone, feel free to tell me, what do you know about probability? Quickly, you can unmute yourself and tell me, what do you know about probability? Is anybody talking?
I think probability might be like trying to predict an outcome, sir.
Really? Have you heard of people saying the probability of winning a lottery, or the probability that it will rain, or that the probability that political office aspirant will win or lose? Have you heard of that?
Yes, sir. Yes, sir.
So, or in what other context have you heard the use of the word probability?
Maybe uncertainty, sir. Like,
Uncertain, yeah, you are now talking gradually.
yes, sir.
So, who else is raising up his hand? Is it Ghanaian?
Yes, sir. It's the possibility of something happening.
The chance, the likelihood of an event happening. You know a coin. How many sides does a coin have? How many sides? If you have a coin, then that coin could have a head or a tail. So if the coin is tossed once, you may want to say, what is the likelihood that a head will appear or a tail will appear if the coin is fair, if the coin is not loaded? So when we talk of probability, then we are talking about the likelihood, the chance, the possibility. But it is usually in a metric form, which means it's measured. So it goes beyond just saying is highly likely or most likely or unlikely, as you probably want to do in the linguistics, but it's measured. So probability is measured. In other words, it has to be measured precisely. So maybe there will be a value attached to that measurement. So how do we compute that value? This is what you have. This is the formula for computing that value. So what is this formula? It is the number of favorable outcomes over the total number of outcomes. So in this simple experiment of tossing a coin, one, we need to determine what are the possible outcomes. So the possible outcomes are head, tail. Then that gives you the total number of outcomes. Then you also need to determine which outcome is considered to be favorable. Which one are you interested in? So in this case, if you are interested in head, then I will say I'm looking for probability of head. Then I will now count how many times head appears in these possible outcomes. That is the number of favorable outcomes. So in this case, what will be the probability of head? Ganiat. Or anybody else? Lawa, Deborah.
1, sir.
1 is what? Is the number of favorable outcomes. So if you apply this formula, what will be the probability of a head now?
It will be 0.5, sir.
Before you do that, I want the value in the numerator, the value in the denominator.
Okay, 1
The
over 2,
1
sir.
over 2.
It will be 1 over 2. Excellent. Excellent.
So, I
So
don't understand. I don't understand, sir.
you don't understand because you don't want to understand. Do I start all over again?
Yes, sir. Thank you, sir.
Do I start all over again? You came late. And so I said whenever we talk about probability, and I asked Ghanaian, what does it mean? So some people said, yes, likelihood, the chance, no, the possibility of an event occurring. And I agree perfectly with that. But the other thing is that we have to put measurement to it. We have to calculate the value of that probability. So, and this formula gives you the expression for calculating that probability. So to calculate that probability, I said, let's look at the experiment here of tossing a coin. You know, a coin has 2 sides. So, if you toss a coin, then these are the possible outcomes. Head can appear or a tail can appear. These are the list of possible outcomes. And that gives you the value in the denominator, this value, which will now be the total number of outcomes. And that's how you get the 2 here. Then, in the denominator on top, you need the number of favorable outcomes. And that is defined by what you are looking for. So I'm looking for probability of head. So head is favorable to me. And in the list of possible outcomes, head is appearing how many times? 1 time. So which means the number of favorable outcomes is 1. And therefore, the probability of head is 1 over 2. 1 is the number of favorable outcomes, and 2 is the total number of possible outcomes. Is it clear now? Is it clear
Yes, sir.
now?
Yes.
Udo.
Yes, it's clear.
Udo.
Yes, it's clear.
If it is clear, don't mute yourself yet. If it is clear, what would then be the probability of tail? What would be the probability of tail? Udo. Okay, I will guide you. Udo. Udo.
Yes, sir. I'm here, sir. Thank you, sir.
How many possible outcomes do we have? If I toss the coin once, yes. What are the possible outcomes?
I think it should be once, sir.
Don't just answer. If I toss the coin once, what are the possible outcomes? Who can help him? Yes. Yes.
Possible
Lawal.
outcome will be either head or tail, sir.
Excellent. So, what is the total number of possible outcomes now?
Total number will be 2, sir.
Will be what?
2, sir. 2.
2. So, which means 2 will be in the denominator. Then, which outcome am I interested in?
The tail, sir.
Tail. So, what is the number of favorable outcomes out of 2?
That will be 1, sir.
That is 1. So, which means the probability of tail is also half.
Yes, sir.
And Udo refused to really follow. Only Lawal is getting it now. Now let's come back to another interesting example. Let me clean all these ones. Because you need to get this thing before we can begin to really make headway in this discussion. Sorry. So we have another expression here. This time around, another problem, so to say. So we have another example. We want to roll a die. We want to roll a die. How many of you have played the game of dice? Who is talking?
Aye, sir.
I have, sir.
And let me focus on Deborah now that she volunteered. Deborah,
Sir.
when you play the dice, how many sides does the die has?
6, sir.
6. So what are the sides?
1, 2, 3, 4, 5, 6.
So we will say those are the possible outcomes. We call them, those are the possible outcomes. So which means we will have 1, 2, 3, 4, 5, 6. Am I correct?
Yes.
Yes, sir.
So in this case, how many possible outcomes? How many possible outcomes, Deborah?
6, sir.
6. 6. So I can have, so which means if I'm interested in probability of 2, for instance, I'm interested in probability of 2, then the denominator will be what?
6.
6. Thank you. But which one am I interested in?
2.
Then what is the number of favorable outcomes? How many times do I see 2 in this expression? 1. So the probability of getting a 2 is what? 1/6. Is that clear, everybody?
Yes, sir.
Yes, sir.
Yes. So is it difficult to calculate probability now? Is it difficult?
No, sir.
No,
Okay.
sir.
No, sir.
Okay, who said no last? Who said no last? Is it Cassava? Cassava said no last. Then you will show me that you mean what you said. Now. Cassava.
Yes, sir.
So let's say in this class we have 5 students, and let's know their gender. Let's say 3 of them are men and 2 of them are women. So in the class, so we can say men. So which means we have men, 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 then women, women. So if I'm now interested in the probability of men, what will be the probability that if I select anybody randomly in the class, the person will be a man? Yes?
3/5.
Eh?
3/5, sir.
Please clap for him, everybody. He is very brilliant. He's supposed to have studied mathematics, but I don't know. So it's going to be, how did you get your 3/5, Cassava? How did you get your 3/5?
The chances of getting men is, we have 3 chances of getting a man all over the total number of outcomes, which is 5.
So the favorable ones, the number of favorable outcomes in the list is 3. And
Yes,
the
sir.
total number of outcomes there is what?
5.
Is 5. That's how. Now, who will tell me the probability of getting a woman? If I'm interested in probability of woman, a woman.
2/5, sir.
2/5. Who said that? Who said that? Who said that? Who said it?
2/5, sir.
Is it Ghanaian? Is it Ghanaian that said it?
Yes, sir. 2/5.
Eh? Okay, you are correct. I just want to be sure you are the one. So calculating probability is as simple as this. Now let's go back to this particular one. We all know even numbers. Let's say I toss the die once and I'm looking for even number. What will be the probability of getting an even number? Maybe if I just type probability of even number. Who is going to tell me? Yes. Yes. Who is raising Lawa?
That would be 3/6, sir.
3. How did you get that?
That's total number of even numbers divided by total number of possible outcomes, sir. That's we
Good.
have 2, 4, 6. That's 3 even numbers over
Good.
1, 2, 3, 4, 5, 6, sir.
This is an even number. This is an even number. This is an even. Oh wow. This is also an even number. This is also an even number. So there are 3 favorable outcomes out of how many possible outcomes? 6. Out of 6 possible So this is how we calculate probability. And then that's why we say is a measure of the likelihood of an event occurring. It is the measure of the likelihood of an event occurring. And again, we have another interesting example we want to look at. For those who have ever played cards, if you have played the card before, let me know. Has anybody here played card before? The game of card playing. Is it cassava?
Yes, sir.
Okay, cassava. Tell us how many red cards do we have in the pack? Quickly, our time is going. How many red?
26.
26. 26 of them. And then 13 of them are hearts, Abi?
Hearts.
Diamonds, 13, right? How many of them are black cards?
Another 26.
How many? Another 26. So in terms of color, there are usually two colors, red and black. And they have the same number, 26, 26. Now, we want to select a card randomly. That's what is written here. We want to select a card randomly. And we are interested in the red. So we are looking for the probability of selecting a red. And if we use the formula, this formula, then since we are interested in red, we will now say what is the number of favorable outcomes. In this case, how many cards are red? How many cards are red? Nobody is answering me.
26,
cards.
26.
26, sir.
So out of how many? That is the denominator. Total number of outcomes. Out of how many possible now? Out of
52.
52.
52. And you can use calculator to convert it to decimal place. So this is how we get we compute probability. No, there are other things we can do, but we'll continue. Dr. Peter, later we also have tutorials with you, and Honey, we will have tutorial with you. But this is just to provide you. No. Let me ask you a question randomly. So, let's say you have in your family, let's say, I don't want to use Ghanaian as an example now. Maybe I can use Lawa. Lawa,
Yes, sir.
are you married?
No, sir.
Why
Not
are you
yet, sir.
laughing?
Yes, sir.
Who said yes, sir?
I'm not
Lawa.
yet married. sir.
Deborah said, oh, Deborah left. Okay, you have not married. Okay, but you still have parents, right?
Yes, sir, I do, sir.
How many of you are the children of your parents?
We're 3, sir.
You are 3.
Yes, sir.
How many of you are male?
2, sir.
2. How many are female?
1, sir.
Now, if I want to select a child randomly from that family for a scholarship, what is the probability that I will select a female?
Female, that'll be 1/3, sir.
What is the probability if I select anyone randomly? That person will be a male.
Male will be 2/3, sir.
2/3. Excellent. So that's the formula for computing probability, which means you can always use that formula to measure the probability of an event occurring. And you simply, for you to use that formula, you must first of all know all the possible outcomes. It's very important. Then 2, you must then know what outcomes are favorable to you. So will you now calculate, favorable outcomes, count how many outcomes are favorable, divided by outcomes divided by the total number of possible outcomes. Is that clear, everybody? Everybody now here, we spent about 45 minutes discussing, defining what probability is all about. But that's not the only thing we have to do. So that takes us to another very important definition. This time, conditional probability. Conditional probability, right? Okay, let's say in the case of Lawal, the first child was, what's the gender of the first child? Male?
Male, sir.
Followed by?
Female, sir.
Female.
Yes, sir.
And then the third one?
Male.
Male.
Yes, sir.
Am I correct? Huh?
Yes, sir. Yes, sir.
Okay. So I may be interested, just like we said earlier. Let's say I'm interested in the probability of male. So, and we have agreed that the probability of male is 2 out of what? 3. Out of 3. 2 out of 3. Now suppose I've selected male and now go further the second time. This is the first time. The second time, I'm still looking for a male. So given that I've selected a male in the first, this is where conditional probability comes in. I'm looking now for probability of a male. Given that, that's what that line is simply saying, given that, supposing that, assuming that you have selected male the first time. Who will tell me the answer now? Remember, I've selected male in the first, which means maybe this is the one I selected. But I'm still looking for a male now. What will be the probability? Lawa.
Sir.
Udo.
The probability will be 1/2.
1/2.
You will select a male given that. Yes, sir.
Because I'm only left with what? Since I've selected a male, I'm only left with 2 possible outcomes.
Yes, sir.
I can see Udo saying 0. I will give you 0 for that, which means you have started scoring 0. How can you do? How can you? Udo. Udo.
Yes, sir. Yes, sir.
Your 0 will be as big as your head, the way you have just.
Pardon me, sir. I just woke up from sleep now, sir. I'm sorry, sir.
You have to wake up, shine your eyes. Don't sleep
Yes, sir.
again.
Okay, sir. Thank you, sir.
You don't even sleep until tomorrow. So I've already selected a male in the first. And therefore, I'm only left with two children, a male and a female. Therefore, if I'm to select a male again, I will only have 1 out of 2. So conditional probability is usually defined as the probability of event A occurring, given that event B has already occurred. So this one here is the event that has occurred. This one here is the event that we are now interested in. Yes. Yes, who is raising up hand? Who is raising up hand? The person cannot talk. You are muted. The person is muted. Is it Joseph? Joseph. Okay, so.
Not me, sir.
Okay, not you. Who is
I was
raising
the
up?
one, sir, but that was a mistake, sir.
Okay, Kafayat. Okay.
Yes.
I didn't even know you have joined. Yeah, so this is very important before we now move to another concept entirely. So the probability, the conditional probability is the probability of an event A or any event defined, any event for that matter occurring, given that B has occurred. So in this formula, A is the event we are interested in, given that B has happened. And this is the formula that we will use for calculating this probability. So this probability, the one on top, is the probability of both A and B occurring divided by the probability of B occurring. So the one on top here is the probability of both A and B occurring divided by the probability of B occurring. So what that means is this. Sometimes maybe I have to use what we call Venn diagram. So if you have two events, this is A, and another event, this is B. This is A, this is B. Where this place is where the two of them intersect, and that is usually where we call the probability of A. This place is the intersection A intersection B. That place is A intersection B. So you will see that this part is the part that is common, or put differently, the part of B that is in A. This part is also the part of A that is in B. This is A, this is A, this is B, but this is one that is common to them. This is what is common to them. Yes, who is there? Who is talking? Mute yourself and speak quickly. Okay. Since you are not talking, I don't know what to do.
I can't see your arrow moving anymore, sir.
Eh?
The arrow, I can't see it moving anymore.
You can't see the arrow.
Yes.
Which arrow are you looking for?
The cursor that you are using to point out
I
at
think she
the
has to log in and log out and log in again, sir.
I was using my, okay, let me use the cursor so that you can see.
Sir, I think
Yes.
she has to
Do
log
you
out
see
and
this
log in,
now?
sir.
Can you
Yes, I'm
see
seeing it, sir. I'm seeing the one that you are using now, sir.
Okay. It's good to
Yes, sir.
talk. Now, what I'm saying is, this is event A, right? Let's say event A is referring to linguistic students. So linguistic students, let's say L. And in that linguistic student class, we have male, we have female, we have female, right? And then in the statistics, let's say we have male and we have female. So, which means A here, we are going to, let's put name instead of male, female to make it, to make it, let me erase that so that to be, so let's say in the linguistic class, we have students, we have, let me use state of origin. No, maybe we have Oyo, Ekiti. We have the rest, I think, are let's say Lagos. So, and then we have in statistics, we have also Oyo, but we have Kwara. Yes. And we have which other one without yes, Kwara, Rivers State. Thank you very much. So if I draw the Venn diagram the way I have here, if I draw the Venn diagram, I'm struggling with, yes. So if I draw the Venn diagram for L, for linguistic, this is linguistics. So which means I will have E and I will have L. There will be O here. Great. But if I now want to draw for statistics, then I will have statistics here. And then because Kwara is not in linguistics, and I also have what? Rivers, which is also. So what we notice here is that Oyo is belonging to linguistics, and also it also belongs to Oshun, right? I hope you are following me. Nobody is following me.
Yes, sir.
Good.
Yes,
So,
sir.
so in this intersection of L intersection S,
Yes, sir.
this is intersection. There is only one element there, and that element is Oyo. That element is Oyo. So we say that this intersection is the part of L, is the part of L that is in S, and is also the part of S that is in L. Always remember that. Therefore, when we are calculating the probability, let's say I'm now interested in the probability of selecting somebody from, I'm interested in the probability of L given S. Then that probability is, in other words, I'm interested in the probability of selecting a student in linguistics class, which is of Oyo State, or which is in a state in the same state in statistics class. So that means I will have to find the probability of L intersection S divided by the probability of S. So, and to calculate this probability, again, you have to use this formula, which is going to be the number, the numerator, which is going to be the number of those in those favorable, those who have the same state of origin, Lagos and Osun, So consider it also with the possible outcomes. And then also the probability of S, statistics, which will be the number of favorable outcomes. In other words, those from Osun divided by the total number of students in statistics class. So this formula gives you the expression for calculating conditional probability. But there are easier ways to calculate this kind of probability, which is very, very important, which will lead us to another very important aspect. So what is that? How do we compute that? So one major way, so when we say probability, when we say probability of A intersection B, We can also write it as probability of A times probability of B given A, which means we can write probability of A and B by saying, well, probability of A times probability of B, given that A has already occurred. Interestingly, there are two ways of writing this. I can also write it as, if I don't start from A, because I told you earlier that we could read this as this intersection, we could read it as the part of S that is in L. So if I continue to use A and B, then if this is A, this is B, then I can say this intersection is the part of B that is in A, right? So I can also say this intersection is the part of A that is in B. So I can also have A intersection B to be equals to probability of B times probability of A, given that B has already occurred. So we have these two ways, of writing this intersection, the probability of this intersection. And you have example here, very interesting one. For instance, if one is interested in probability of an email being spam, given that it contains the word congratulations, which means we have to look at the mails. The numerator will look at the intersection of spam, all the spam emails, and also all the emails containing the word congratulations. And so we will now look at the numerator will give us the intersection of spam emails and emails containing congratulations. So that gives you, if you are to write the formula now, and you are to follow this same expression, then the conditional probability of spam given or the conditional probability of an email being spam, given that it contains the word congratulations, we can now use this formula to expand it. And then that becomes the probability of spam intersection congratulations, then divided by the probability of congratulations. So this is the formula that you will apply. But this numerator is what I expanded this way, which would then be probability of spam times probability of congratulations given spam. Or we say it is the probability of congratulations times the probability of spam, given that the word congratulations appears in the email. So you should be able to define what a conditional probability is. And that leads us to another very, very important concept. You will notice here that, well, we are still talking of conditional probability. Remember, the numerator should have been probability of A intersection B, sorry, of A intersection B. But I've now used the formula, one of these. So I've now used one of these expressions. So, and you can derive this expression yourself. Since we said this could be, so let me clean it. So since we said, okay, probability of A intersection B can be written as probability of A times probability of B given A. And at the same time, I can write probability of A intersection B as probability of B times probability of A given B. Since this is equals to this, it means I can equate this to this, then which means I can write as probability of A times probability of B given A is equals to probability of B times probability of A given B. Wow. So, which means that since the two are the same, so I can make this one the subject of the formula now. So if I make probability of A given B the subject of the formula, then I will divide both sides by probability of B. So which means I have probability of A times probability of B given A. So given A over probability of B. So this is how we arrive at this new formula. So this new formula, this expression that we see here is called the Bayes Theorem. It's called the Bayes Theorem. You don't need to memorize all of this for those of you in the linguistics, but you will see the application and then you will need to, that will help you to understand what is happening. So this expression now, I can clean up this stuff. Wow. Okay, so let me change my power source.
Hello, Prof.
Yes,
Any issues?
I'm trying to change my power source.
Okay, sir. Okay.
So, okay, so we have this expression now for calculating the Bayes, for Bayes theorem. This is what we call the Bayes theorem. This is what we call the Bayes theorem. And it's simply an expansion, so to say, of the conditional probability. And as you can see it, we can also read it as the conditional probability of A given B, which means it is this expression. The numerator, you have the probability of B given A times the probability of A divided by the probability of B. Whatever is here, remember, is always going to be here. And then whatever is the numerator will always be an intersection of A and B, but can be expanded this way. Now, it's expanded because of something. It's expanded because each element here, or each term here, has a meaning, And the first one here, probability of A given B, is what we call the posterior probability. So this term, apart from just calling it conditional probability of A given B, in the Bayes theorem, this is called the posterior probability. Again, in the Bayes theorem, this expression, probability of B given A, is called the likelihood. It's called the likelihood. And then this one, which does not have any condition attached to it, is called the prior probability. That is usually the probability that we know even before we carry out the study about spam. So in the example of probability of spam given, given that the email contains the word congratulations. We are interested, probability of A here, which is called the prior probability, gives us what we know about the probability, the chance that an email will be a spam. And B now is the evidence. That is, in this situation, is the probability of observing that word congratulations in any email. So B, probability of B is the evidence. Probability of A is the prior probability. Probability of B given A is the likelihood, and probability of A given B is the posterior. So the new vocabularies that you need to master are posterior, likelihood, then prior, and then evidence. Evidence. And again, that's the so in Bayes' theorem, the goal is always to compute the likelihood that an email is spam, given any word. Maybe congratulations, maybe word like you have won, or win, or won, or those common words they use, you know, in spam, emails. So we can apply the Bayes theorem. Interestingly, the Bayes theorem can be applied to text classification, which is our goal. That's why we are studying this in this class. Our goal is to apply this Bayes theorem because of its usefulness to say, okay, can we classify any document, any email, whatever, based on by using this theorem? Can we classify an email as spam or not spam? Can we? So, yes, because look at this example, for instance. In this example, we want to classify an email based on whether any word like win a prize is contained in that email. It's not all emails that carries congratulations, for instance. It's not all emails that carry win a prize that is a spam. But what is the likelihood that the email is a spam if it has this word? So the probability of spam, the probability that an email is a spam, given this expression win a prize, can be computed using this. And the probability will now be used to classify. If the probability is high, then we classify it as being a spam. We can categorize that email as spam. If the probability is very small, that is, the likelihood is very small, then we will say, no, it's not a spam. So this is how the Bayes theorem helps us to now classify. So it's very, very useful, very, very, in most cases, very accurate when it comes to predicting classification. So we call it classifier. Any machine learning tool that is able to discriminate whether spam or not spam, whether it will fail or it will pass, whether it will default or not default, and so many other, whether it will graduate or not graduate, whether it's a cultist or not a cultist. Any machine learning algorithm that is able to classify any new observation, any new individual into a group is called a classifier. So, but this technique, this approach of using Bayes theorem has three key challenges. When we use this approach, it's a statistical approach, or mathematical as well. When we use this approach to classify email, for instance, or to classify an individual, there are key challenges. One is the computational complexity, as you will see here. You can imagine how difficult it will be if you have to compute all words. We have talked about, spam giving congratulations, but there are other words apart from congratulations, maybe millions of other words that spammers also use in their email. So are you still able to see my slides? Somebody said the slides are not visible. Are you able to see my slides?
I can see it. I wonder if they can see it.
Yes, sir. We can see it now, sir.
Okay, I was just moving around to, I move around to another slide. So if we have to compute the conditional probability of an email being spam, given almost all the other words that are possible, is just not is possible, but it's just going to be overwhelming. So that's what this is saying, that the computational process is complex and may be very expensive. Another limitation is the data sparsity. When we talk of sparsity, is about, how often are the words used. There are words that are, are rarely used. So you may have some words that are, they can be used, but they are rarely used. So they can feature, and that may also make this model not to perform very well. So because it will not, you won't have enough to train the model. So, and if you don't have enough words to train the model, then the model will not detect when there is a spam. Someone wants to join the meeting. Try to verify. Okay. So the third major limitation of this Bayes theorem when it comes to application in text analysis is the independence assumption. For instance, we've just talked about win a prize as a word. Congratulations as another word. So what we are saying when we talk about independence is that we are assuming that words are used randomly, that words are not related in any way, that win a prize is not related to congratulations and to some other words. That's independence. Independence simply means the words occur randomly and they are not related. But we know that this is not completely true. So, in text classifications, these are the major challenges: computational complexity, data sparsity, independence assumption. So what is the solution? What is the solution? The solution is Naïve Bayes classifier. Now we have moved from Bayes to Naïve. So anybody now will be curious, what is the meaning of Naïve? Does anybody know the meaning of Naïve in the class? When you say somebody is naive, Adedeji, okay, Kasaba, you are almost going to say something. Go on.
Novice, sir.
Eh?
Naive means when that person is novice or gullible.
Is gullible? No. Yes. When somebody is you may even say that person is is not knowledgeable. Is simple. A naive person is
like
yes.
when someone lacks experience.
That person lacks experience, so he's not sophisticated. He's not sophisticated. So but that takes us to the sense in which we are going to use it in this, or the sense in which it is going to be used here. So, and I've mentioned it earlier, is assume that the words are independent. So, which I said is so simple, it assumes the most simplistic, we can regard it as the most simplest, the simplest assumption that can be taken. Even though it's the simplest assumption, or it's a very simple assumption, but it's been found to be very effective. So, not that it doesn't have its side effect, but it's been found that though simple, but compared to others, it's effective. So that's why it's used as, it's called Naïve Bayes classifier. So it's a classifier using the assumption. It classifies into groups or into classes using Bayes Theorem. That's number one. And assume independence between the words. So you're already familiar with this formula. It's the same formula that we have there, which is, so C here is referring to the class. In this case, the class could be spam or not spam. X here is referring to the words in the email. Words like congratulations, words like prize, you have won a prize, and other words like that. So the list of words that you are considering are called the features set. So, and you now apply that formula, which is the probability of the features given the class multiplied by the probability of the class over the probability of the features. So put differently, this is your posterior probability, this is your likelihood, this is your prior probability, and of course, as we've said earlier, this is the evidence. Remember those things. So, interestingly, we've talked about two classes. So we talk about spam and not spam. We could also talk about default, not default. We can also talk about graduate, not graduate, or fail to graduate. So when we have two categories like this, we call it binary. Binary. Binary simply means two. We can also have, we can also call it dichotomous, and many other expressions like that. But we could also have other variants where the groups may be more than two. So we can have situation where you have more than two categories. I'm trying to, maybe a common one is usually in the economics in the economy, or maybe if you are talking of exchange rate, I don't know if you are familiar with that. So we can say exchange rate depreciates, exchange rate appreciates, and there may be no change, no depreciation, no appreciation. That's three categories. So when we have three or more, that's when we talk about multinomial. And this can happen.
Prof.
Yes.
Prof. So you can use it in the prediction of football matches, whether a team will win, a team will lose, or a team will draw. So that has three levels.
That's also
win, lose, draw.
Thank you very much. I think Kasaba would like that. Those of them who are football fans. Udo, are you also there?
Yes, I'm here, sir.
Which is your favorite team? Which is your favorite, so to say?
I prefer football, sir.
Huh?
Football.
I know football, but which team is your?
Okay, Liverpool, sir.
That's what we are saying. So if we are dealing with sport, we could have win, lose, we could also have draw. So in situations like that, you can use binomial. I've talked about binary here. We could also call it binary Naïve Bayes, where you have only two categories. But when you are dealing with continuous valued features, continuous simply means they are not in categories, but they are in measured quantity. Then we say it's continuous, and we apply the Gaussian-based Naïve Bayes. We will still use this, but later. And we will also still use this, but the simplest one we are starting with is this one. So we will start with Bernoulli Naïve classifier. So that's the summary of what we have. Because of our time, we will quickly run through a demonstration of this approach using the R package. And then maybe later, Dr. Peter will be able to do more tutorial with you. So if you want to apply this technique, I think you can see my screen. Is anybody?
Yes, sir, but it's no bold.
Eh?
It's no bold, sir.
Okay. Let me see if I can make it bigger. Is it better? Or I should do more?
Please do more, sir.
Options for the
Please do more, sir.
Is it better now?
It's better now, sir.
Yes, sir.
Thank you, sir.
So, Inioluwa, well done. You are the only one talking. You won't take no for an answer.
Thank you,
That's
sir.
good. That's good. So, how do we implement this Bayes, Naïve Bayes approach in R? You need to install two packages. And the first one is the text, TM, the text mining package. So you can see TM. I've installed it, text mining package. So if you, I'm sure by now most of you must have installed your R package. You won't be able to do anything if you don't install that package. Then the other package is the E1071, which is the miscellaneous functions of the Department of Statistics Probability Theory Group. Is in Tennessee University. Am I correct? I'm not sure it's Tennessee University, but TU. So once you install the packages, you can use line 4 to load the text mining package. You run it, and then you use line 5 to load the E1071 package. You do that. The Naïve Bayes is actually in the E10 package. So you can know more about this package here. So just go to search for it, and yeah. So once you search for it, E1071, and you click this, that will help you to see more functions and arguments that you can use. So take time to read the documentation for the package. Now we start the work. What text are we looking for? So we will have our data. We just create this simple data, which we call the text data. And in the text data, you have win a prize. This is not spam. Congratulations, you won. Then meeting at 3 p.m. These are some of the words, which can come up in any email document, in any email message. So we regard them, we save them here as text data. So if I run this, I can even see the data as in the memory. So what has happened now is that R has saved the first one as number 1. No, this as 2, this as 3, and of course this as 4. Anytime you are storing text documents, you have to put them in quotes. Now, we have another here, which is another, the label. So this win a price now is actually a spam. This is not a spam. It's not spam. Congratulations, you have won. It's a spam. Meeting at 3 p.m. is not a spam. So every word there, we have a label attached to it. And again, all the labels are collected and stored in this
Object.
object. Thank you. In this object called labels. So we can run this now. And then if we still want to see how they are stored, we have them here. The next thing is to convert the text data into corpus. So we have to use the corpus function. So, and save it in the corpus object. This is the text data that we are converting to corpus. So we can run this. If you want to see the corpus, you can also view the corpus, which means there are 4 documents in the corpus. If you recollect the definition of corpus is the collection of text documents. So there are 4 text documents here. That's what is being reported in the corpus now. So having converted them to corpus, we have to clean the words, the data. And to clean the data, we have to transform all of them to make them all to be lowercase. That's what this will do. And then it will save a corpus clean. Now, if we want to see, of course, we can, well, we have some of them that already. So again, we still have our corpus and we still have the 4 documents. Then to remove punctuations, line 16, those are the cleaning tasks that we need to accomplish. To also remove stop words, then we run line 17. And finally, we can convert the corpus, the cleaned corpus, we can convert it to document term matrix. You will still get to know more about this as we continue. So once the cleaned corpus is ready, then we use the document term matrix function and save it in the DTM object. So we can run this now. So our data now will have to be in form of frame. In a frame, you have the rows and the column. So that's how data frame is constructed. So we are now converting the DTM to matrix. So we use the function as matrix and then convert the matrix to data frame using the function as.data.frame and save it in the data object. And it's easy for you to see the object now, hopefully. So this is what has been saved. So we now have the word now. Now is appearing here, 1. So price, this is spam, this is congratulations. So in the document 1, you have now, you have price, you have win, no spam, no spam, no spam, no spam. In the document 2, the only word there is spam. in the document 3. That is in the, you have 4, remember you have 4 documents now in your corpus. So in the document 3, there are only 2 words there, congratulations and 1. And in the document 4, there is only 1 there, meeting. I think you can also, you can look at this is the first document. So you have there now, you have price, you have win, that's all. In the document 2, you have only 1 word there. All the other ones have been, you have cleaned them up. So you have spam. In document 3, you have congratulations and 1. In document 4, you have only meeting. So I'm sure you understand what is happening there. But we need to, in the data frame, we need to include the label. That is the label here, because each word we need a label that will indicate whether it's spam, not spam. Those are the 2 categories, spam, not spam, spam, not spam. So let's run that line, which is, where is it? Yes, line 24. So if I run it, you can go back and see the data now, and then you will now have the label here. So you have document 1 is labeled spam. And because document 1, win a prize, is labeled spam. Document 2, this is not a spam. It's labeled not a spam. Document 3, which is congratulations, you won, is labeled spam. Congratulations, meeting at 3 p.m. is labeled not a spam. So this is data frame. Data frame with columns and rows. And you also have up to this place down. That is those are the features. And here, this is the label. Remember, in our expression, we said, so the class will be the label in this case. This C is the label, and this X is the feature set, which will be the words that you see there. These are now, price, win, spam, congratulations, won, meeting, and so on like that. So those are the words. Good. We have only succeeded in preparing our data. So we have prepared our data now. And the next thing is to train the Naïve Bayes algorithm. We need to train the Naïve Bayes algorithm. But before we train it, we need to split our data into 2. First, the training set, and then second, the test set. Unfortunately, we don't have plenty of data here. So, but notwithstanding, we use what we have. So we set a seed to randomly do the splitting. So by setting this seed 1, 2, 3, it is helpful. You could use any other set of numbers here, but if you use any other set of numbers, you won't be able to reproduce exactly. So you will be getting different results. So we now use line 28 to create the indices, so which we randomly sample, which we create random samples. We are randomly selecting 3 out of 4 because the number of rows we have is 4. So if we run this, then you may want to see those random indices that have been selected. So which means row 3 is going to be in the training set, and row 4 is going to be in the training set. Row 1 is also going to be in the training set, but row 2 will be used as the test set. So all those that are in training set will be collected in line 29. If you want to see them, you can run now. You will see 3, 4, 1 have been collected and stored in the training set. Then the test set will only have 1 row. So which means you can now run this to see. This is number 2 row that is left as test data. Fine, it's because we don't have too many words. Maybe one thing you can do also is to increase the number of text data, which you can try your own. You can even just collect few spam emails and get the number of emails, so to say, and collect some of the words they use. Now we have split the data into trained data and into test data. And having done that, we now build our model. And this is the model. To build the model, you have to use the Naïve Bayes and use this is the argument. The first thing there is the label, followed by the tilde. And then this dot simply means it's going to use all the data. Now spam, we are dealing with the trace. So it's going to use everything here, every data point in the trained data. So this argument is giving the data that will be used, trained data. And then the data will now be used to train the Naïve Bayes. So that will give you the trained model. And you can run that model. The result is stored here. You can see the result of the model, but there is no time to. It's quite interesting. So this is the result of the model, which is you have the details here. So Naïve Bayes classifier for discrete predictors. So here is just giving you the formula used, and then the principle that was used for the analysis. So these are the probabilities that we talk about. This is giving you the a priori probabilities that we talk about. So this is the probability of not a spam, 0.33 in the data. This is the probability of spam in the data. These are the conditional probabilities that we talk about. So, for instance, for now, this is the conditional probability of now, given that it's not a spam, is 0. The conditional probability of the word now, given that it's a spam, is 0.5. No, the conditional probability of price given spam. So these are conditional probability tables. Congratulations. So the conditional probabilities are computed for all the words. For all the words, starting with now, price, win, spam, congratulations, won, meeting. And then you can now, compute use the model to predict the test data. What is the test data? This is the test data. So we want to predict, have our predictions for the test data. So let's look at the prediction. So again, you can run this. So you have the prediction is that the only word in the test data which is spam. The prediction is that spam is predicted. Spam has not spam and spam. So we can use the table here to compare predictions and the test. The truth. This is the predicted. This is going to give you the actual. So we are comparing the predictions with the actual. So a table will be created, and that is the table. So the prediction here, not the spam, is 0. No, spam is 1. Of course, you expect that because the only word that you are predicting whether it will be spam or not is this. If I change the set seed, for instance, let me say I use another set seed. Let me just use another set seed. It will pick set of numbers. So I can run this. But before we go, let's see what data you have there. Let's see the indices. Let's see the indices. This time is using 2, 3, 1. Remember, the ones selected before were 3, 4, 1. So it's selecting 2, 3, 1. Okay. And then the training set will be 2, 3, 1, 2, 3, 1. So, and then the test. So we can run the model again using that. And then we can do our prediction using that. We can now see before we do this prediction, let's look at our test data. This is let's see. Yes, so in that test data, meeting is our interest. So we are predicting whether meeting is going to be a spam or not. So let's see the result from this table. So prediction, given that it's not spam, is 0. Given that it's spam, is 1. So this is how we use, when the probability is 0, it means it's impossible. When the probability is 1, it means it's sure. So remember that, but generally probability values will lie between 0 and 1. But it's just the nature of the data we have used to demonstrate. So this is a good place. We have stayed 10 minutes extra. Most of you didn't join the class early enough. So this is where we are stopping. I will upload this script file also on our WhatsApp. Sorry, on our, not on WhatsApp. I won't do it on WhatsApp, but in our Google Classroom. Any question? Any question? Any question? Or I should ask question? Yes. Who is?
Yes, sir. Thank you, sir.
Good on. Go on. Yeah.
Yes, sir. Sir, thank you very much. I want to ask, when are we starting the tutorials? Because actually for today's lecture, my network was really disturbing me. I was coming in and going out, and I missed so much. So I want to know when will the tutorials start, and I hope it's not actually going to be virtual because of few challenges. Thank you very much, sir. That's the inquiry I want to make. Thank you.
That's fine, but Dr. Peter Honey Kafayat, are you still on the call?
Kafayat has left, sir.
Kafayat has left. Okay, but Peter, you can, the tutorial, discussion on the tutorial can continue on the WhatsApp. They need to look at their schedule and be able to fix the time. But the starting point is for you to watch this video again. Is that okay, Udo?
Yes, sir. Very okay, sir. Thank you.
So once the video is compiled, I will upload it on our Google Classroom platform. It will also be on my YouTube channel, in case you prefer that one. Any other question, good or bad? Inioluwa, are you in the class? I'm not sure.
Yes, sir.
Did you speak at all?
I spoke, sir.
Okay, Kafayat, I can see you now. It's like you are back. Kafayat.
Yes, sir. Good evening, sir. My network went, so I had to rejoin.
Okay, so you will, Peter will coordinate. Maybe he might decide to ask any of you to assist with the tutorial, or he can as well work on the tutorial. So, any other question? Ganiyat, are you okay? I know maybe you struggle to be okay.
Yeah. When I go over the video again.
Okay. So thank you all. The class for 751? I will schedule that class hopefully before the end of the week. It might be an evening like this, but I'll let you know. So bye. Thank you very much. See you.
Thank you, sir. Bye-bye, sir.
Bye.
Thank you very much,
Thank
sir.
you, sir. Goodbye, sir.
Thank you, sir.
Yes.